Okay, hello everyone. I'm Giovanni, and today I will talk a bit more about the effect on time on causal algorithmic recourse. So I usually start this presentation with a story, but Nicholas today did the job for me. So we consider the scenario in which, for example, we have Alice, okay, that applied for a loan at her hometown bank, but the bank employs a very sophisticated decision-making tools that denied Alice her loan application. But unfortunately, Alice has no way to understand how to, let's say, overturn the decision because the decision-making system is very complicated and black box. So the main question in general of recourse is answering the question, how can we help Alice, let's say, overturn this outcome? And the answer usually is we try to do this by giving actionable explanations that make her understand why and how to act to overcome this burden, let's say. So in general, in the literature, these are called recourse recommendation, and they come in a counterfactual fashion. And the idea would be give to Alice certain feedback in the form of, okay, if you had increased your income by, for example, 3%, then we would have given you the loan. We talked about feasibility before. In the context of recourse, we need to ensure that these actions are kind of doable by Alice. So in our setup, we formalize everything through a structural causal model that you can see on the left that tell us basically how features kind of interact probabilistically between each other. And in practice, a structural causal model is made by a structural equation on the left that kind of describe how these features, let's say, interact in a parametric form usually. And together with some exogenous factors that add some, let's say, noise to the distribution and make everything, let's say, less deterministic. And in general, in the algorithmic recourse to causality, everything boils down to solve this kind of optimization problem. Which basically means we need to find a recourse that generates an improved individual that obtains desired classification, for example, in expectations, so obtain a classifier with expected score above a certain threshold, and that minimizes a certain distance matrix or cost metric between the original individual and the improved one. Since we're talking about causality here, the recourse here is an intervention that we do on the causal graph through a do action. And we can either have, let's say, superpopulation recourse, so that you do in an interventional fashion by conditioning on certain protected attributes, let's say age or gender or whatever. And also we have the counterfactual version, which is the true recourse, which is individualized, and let's say is the optimal goal that we would like to achieve. So first we notice that unfortunately everything, say in the literature, assumes that kind of recourse actions tend to be instantaneous, so that the person can actually do them immediately. But unfortunately, implementing and realizing, let's say, these actions kind of take time, and also when you do them, let's say, can generate diverse effects on the data distribution. For example, improving your debt to income ratio, acquiring a degree might have a different effect depending on your age, on your career history. So in our paper, we try to answer the question, let's say, how does, for example, robust causal recourse behave over time? And in general, for example, if we consider our non-stationary time series described by a causal process. So the answer might be not surprise anybody, but in practice, causal recourse is very brittle over time. And here we did some synthetic experiments on synthetic and semi-synthetic scenarios by considering several, let's say, state-of-the-art robust causal recourse approaches. And the idea is that because we can actually find a trend in the data that can basically cancel out any intervention, any recourse that we can suggest to the user. And as we can see, as the strength increases, then the recourse validity kind of drops for all the methods we considered. Further, in the context of counterfactual recourse, which would be, let's say, the optimal solution for our problem, we cannot see that unless the exogenous factors in our causal graph have, for example, zero variance, okay, counterfactual recourse is really not possible if we consider this kind of time series scenarios. And again, even here, as the variance of the exogenous factor increases, then our recourse validity kind of drops significantly. So we argue that under the hood, recourse is actually a temporal task, and it looks like something like this. Basically, this is our time series described by a causal graph, and the users ask us, okay, how can we actually achieve recourse so obtain the desired classification at a specified point in time when I will be able to perform all the action you're actually giving me. And therefore, the real problem is something that you can see on the bottom here, where basically we need to consider the future individual. So how the user will be when he will be or she will be able, let's say, to perform these actions. In our paper, we kind of argue that kind of like time is understudied in the course literature. And in our paper, we kind of try to formalize, theoretically, a notion of temporal causal recourse through the lenses of causality. We cannot demonstrate through some proposition and theory that uncertainty and non-stationarity of, for example, the causal process can hinder causal recourse, even the robust version. And then we try to propose a time-aware algorithm that kind of addresses these issues in, let's say, in various scenarios, synthetic and semi-synthetic scenarios. So our main contribution is, let's say, we ask ourselves, okay, but what if we had access to, let's say, an estimator of the causal process, okay, that we can learn from data in a data-driven manner. And the idea is that we try basically we can try to provide a robust recourse to time by using something called like temporal uncertainty set. And the idea is that we want our recourse, for example, here imagine that the recourse that get a positive classification in the gray area, we want our recourse to be valid around some regions around the user, but those are forecasted regions around the user that we can do thanks to our, let's say, estimator. And we want our recourse to be valid around all those green ellipses. So we did some experiments over, let's say, synthetic time series and also semi-synthetics, and we saw that by applying this simple, let's say, robustification of recourse, okay, this is a synthetic scenario in which we assume to know the ground truth SCM. We are able, let's say, to our, let's say, approach is kind of achieve almost 100% validity over, let's say, many time steps, while all the other methods robustify the kind of fails gracefully, let's say. Moreover, we also tried in some experiments over a realistic scenario, a lone scenario, and we see that by incorporating, let's say, an estimator of the causal process, learn from the data, we can actually get twice the validity of the best performing robust causal recourse methods. And also we can give to people, let's say, more informed and targeted interventions. For example, here we assume to have, let's say, a trend on the income variable. And while all the methods try to, let's say, ask the person, you should increase your savings, by assuming that there is a trend in the income variable, maybe your income like decreases over time because maybe you age or you get a pension or whatever. The temporal aware approach suggests to change both the income and savings, because the idea is that if you want to increase your savings, you also have to take care of your income, otherwise it won't work. So, it's a very, let's say, after all these methods, we believe that, there is a very long road towards practical recourse. And let's say time is one of the main issues that's going to hinder kind of the process. And we thought that there are a lot of, let's say, things as a community we can do for, let's say, better push this field. For example, we also discussed in our paper about, for example, the lack of good causal model for time series, the lack of good data set to evaluate and to, let's say, measure the impact of these technologies. And also consider, for example, potential ethical pitfalls. For example, the problem of adversarial examples versus actual improvement of the recourse. So, thank you. That's my presentation. Any questions?